Our next section is section 5.7, graphing inequalities in the coordinate plane. You can see basically that is our one goal, and you've done inequalities before, you've graphed inequalities before, so let's do our reminder, as we say. If I asked you to take the inequality y is less than 2x plus 3, since that's in slope-intercept form, you can use the y-intercept of 3 and the slope value of 2 as your guide. And remember, the less than or greater than stands for the shading. So really when you're starting, you're thinking graph y equals 2x plus 3. And double check what I have here. We have our axes, but you can hardly see them. Right here we got our origin. Let's see if I can make a couple lines for you. There's one of them. And the other one's like right here. Whoops. That's doing some crazy things right there. Okay. Let's make this one so you can see the origin just a little better. Okay, from there, now we can see that we have our xy axis, and we would graph up 3, 1, 2, 3, where you can see that's where our point is. We'd start at 3, place a point, and from there we would go to our slope, which we said was 2, which is, so if we start at 3, then we go up 2 to the right 1, up 2 to the right 1, or you could go down 2 to the left 1, 2 negative movements. You would still get that line. Now, I made the line dashed, as you'll notice, because the original inequality was a less than, and less than does not include the line. So I made it dashed for that reason. From there, I want to know where are the y values less than my line. So I'm looking right here. Here's my line. Here's the y-intercept. Why are the y values less than? I look up here, they would be greater. I look down here, they would be less than. So that's why I've shaded this side of that line. The other way that you've probably done this in the past is you've done what we call a test point. You can take a point on either side of your line and choose one that's easy. So 0, 0 is a lot of times chosen. And you would check to see if that 0, 0 makes the equation true or false. So if we did that, 0 would go in for y is less than 2 times 0 goes in for x plus 3. You would do the math on the right-hand side. 2 times 0 is 0. 0 plus 3 is 3. Is 0 less than 3? If 0 is less than 3, which it is, we know we have a true statement. That's the side of the line you should shade, the side that that point is on. So that's doing the test point issue if you have a hard time seeing the less than, greater than. Again, the dashed line indicates you do not have points on the line that make the equation true. So our point 0, 3 would not make this equation true. So points on the line are not part of the solution. Think of it that way. Next one. If we had an equation this time that's in standard form, 3x minus 5y is less than 10, you could rewrite it in slope-intercept form, or you could even use our shortcuts. C over b for the y-intercept, so you'd be taking 10 over negative 5. If you used our shortcuts, and that would give us a negative 2, so the y-intercept, using our shortcut from standard form, and our slope opposite of a over b. So our slope is equal to the opposite of a over b. Opposite of a would give us a negative 3, b would give us a negative 5, reduce that, we would get that 3/5. So if you don't want to rewrite the equation and get it in slope-intercept form, then you can use your shortcuts and you'd still arrive at the same result. So now, knowing our y-intercept is negative 2, so again we're having that problem with lines. But here is 0, 0, so negative 2 And from there, we want a slope of 3 over 5. So up 3, 1, 2, 3, 1, 2, 3, 4, 5. There's our second point. Up 3, 1, 2, 3, 1, 2, 3, 4, 5. There's our next point. We would draw our line. This time, though, it would be a solid line because we have an or equal to. And from there, you have to use the inequality from slope-intercept form. So you look here and say, well, wait a minute, what did I do? I really would have had to have moved the y over, or not the y value, but the negative 5. And so I would have divided by a negative 5, so my sign actually got switched. So y is greater than or equal to, and so I need the side of my line that is greater than my y value, my lines, and here is the y-intercept of our line, so where are the y values greater? Here or here? Choice A or choice B? And you can see the answer is choice A. Again, you could do that test point of 0, 0, put it back into your original equation. So let's do that up here. I'd have 3 times 0 plus a negative 5 times 0 has to be less than or equal to 10. And if you do the math, 0 plus a 0 is less than or equal to 10. Is 0 less than or equal to 10? Definitely true. So 0, 0 should be in the shaded region. Okay, what else do I have for you? If, again, another straight line, you can think of it as 2x plus 4y equals 12 to start with. Your y-intercept using c over b. 12 over 2 is 6. And the y-intercept, you could graph just that. C over b, c over a. You can do them both. C over b, I did that backwards. C over b would be 12 over 4, and that's where the 3 comes from. And 12 over 2 is c over a, which is the x-intercept, is a 6. So you could graph just the x-intercepts. Again, I have my 0 placed. You can sort of see with the white vanishing axes where my axes are at. But again, this has to be a solid because of our inequality has or equal to. And again, ask yourself what would happen. It would be a less than or equal to. I would not be dividing by a negative if I had to rewrite this. And so all the shading should be below the line. If you want to use the test point situation again, which is an extra step but still correct, that would help you as well. So, graph this inequality. As an example, it is ready to go in slope-intercept form. It's only one inequality. So you can see my xy axis here. I should start at negative 5. 1, 2, 3, 4, 5. Place a point at negative 5. From there, my slope is a positive 2. Go up 2 to the right 1, up 2 to the right 1. Do that a couple times. Grab your line tool. And it's y is greater than or equal to, so we know we need a solid. And we're going to start making our line. Take it through the points as much as you can. That would be our line. Accurately graphed. You can move it a little if you need to. And now we need all the values for y that are greater than or equal to this. So again, the question is for you. Is it up above the y-axis? Or is it down below? And if y is greater than this point, I think you can agree with me that we need to be up into this side of our axis. So shade, 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 shade. That side of your line. So you can use colors, you can do shading, but you'll have one line and some inequalities that you should have graphed. Okay, if it's in standard form, I would highly recommend using our shortcuts. So let's get C over B is the y-intercept. C over A is your x-intercept. Start thinking about what those would be, looking at your values. C over B, 8 divided by 4 would be a 2. And C over A, 8 divided by 2 is a 4. Place them on the correct axes. We got an x-intercept of 4 and a y-intercept of 2. And again, draw your line accurately with your ruler. Is a less than, so we definitely want a dotted or dashed in this case. And so pull it in there. Try to get it as accurate as possible. You can move the line a little. And then again, Where should you be shading? Y is less than, we would not be dividing, so Y is less than would give us a shade, again, down in this area. Okay? So that's all you need. Quick review about how to graph inequalities. We should be good to go. See me in class if you have any questions.